StrLookup in Log4j. Now we are focusing on StrLookup. Lookup a string key to a string value. The interface StrLookup. Lookup a string key to a string value. This is in package org.apache.logging.log4j.co.lookup. In this example here, the class mapLookup, a map-based lookup, and this is in package org.apache.logging.log4j.co.lookup, and the class interpolator. This is a proxies for proxies all other StrLookups. This is in package org.apache.login.log4j.co.lookup. Here in the constructor, construct an interpolator using a given StrLookup. And a list of packages to find lookups plugins. Here we are considering context map lookup. In this example, the application would store the current user's login ID in the thread context map with the key login ID. In context map lookup, the context map lookups allows application to store data in the log4j thread context map and then retrieve the values in the log4j configuration. During the initial configuration processing, the first $sign will be removed here. The pattern layout supports the interpolation with lookups and will then resolve the variable for each event. Not the pattern $sign the %sign X and then login ID would achieve the same result. As an example for, we can consider Kubernetes lookups. The Kubernetes lookup can be used to look up attributes from Kubernetes environment for the container application is running in. Here account name, service account name, cluster name, the name of the cluster the application is deploying, container ID, the full ID assigned to the container name, the name assigned to the container, host, the name assigned to the host operating system, labels, all labels formatted in a list, master URL, the URL used to access the API server, namespace ID, the ID of the namespace the various Kubernetes components are located within, namespace name, the namespace the various Kubernetes components are located within, pod ID, the pod's ID IP number, and this pod's ID number, and this is pod IP number, pod's name, the name of the pod, image ID, the ID assigned to the container image name, the name assigned to the container image. Here we are considering lookups. Lookups provide a way to add values to the Log4j configuration at arbitrary places. They are particular type of plugin that implement StrLookup interface. Now we are considering context map lookup in lookups. Not that the pattern here $x logging ID here would achieve the same result like here. The context map lookup allows application to store data in Log4j thread context map, then retrieve the values in the Log4j configuration. In the example here, the application would store the current user's logging ID in the thread context map with the key logging ID. During the initial configuration process, in the first $sign will be removed. The pattern layout supports interpolation with the lookups and will then resolve the variable for each event. Note that the pattern here would achieve the same result, this $x here. Now we are considering date lookup. The current date or the date associated with the current log event will be formatted as specified here. The class simple date format in java.text, the simple date format is a concrete class for formatting and passing dates in a local sensitive manner. It allows for formatting date to text, passing text to date, and the normalization. The class date lookup in package org.apache.login.log4j.co.lookup in module org.apache.login.log4j.co formats the current date or the date in the log event. The key is used as a format string following the java.text.simple date format date and time pattern strings in the API. The date lookup is somewhat unusual from the other lookups, as it doesn't use the key to locate the item. Instead, the key can be used to specify date format string that is valid for a simple date format. The current date or the date associated with the current log event will be formatted as specified here. Now we are considering Docker lookup. The Docker lookup can be used to look up attributes from the container in the application is running in. The Docker lookup can be used to look up the attributes from the Docker container the application is running in. The Log4j Docker provides access to the attributes. Container, here the container ID, the full ID assigned to the container. Here the container name, the name assigned to the container. Here the image name, the name assigned to the image. This lookup is subject to the requirement listed in listed at the Log4j Docker support section in the documentation. Now we are considering environment lookup. The example here includes the name of the currently logged in user in the application log. The class environment lookup in package org.apache.login.log4j.co.lookup in module log.apache.login.log4j.co looks up keys from the environment variables in the API. Environment lookups allow system to configure environment variables either in global files such as /etc/profile or in a startup script for applications, and they retrieve those variables from within the logging configuration. The example here includes the name of the currently logged in user in the application log. This lookup also support the default value syntax. In the example here, when the user environment variable is undefined, the default value jdoi is used here. Now we are considering event lookup. In this example, the routing appender picks a route based on the presence of the marker named audit being present in the log event. The class event lookup in package org.apache.login.log4j.co.lookup in module log.apache.login.log4j.co lookups values from the log event in the API. The event lookup provides access to the field within the log event from the configuration. Here the key marker that returns the name of the marker associated with the log event if one is present. In this example, the routing appender picks a route. In this example, the routing appender picks a route based on the presence of a marker named audit being present in the log event. Now we are considering Java lookup. For example, here the Java lookup in package org.apache.login.log4j.co.lookup in module log.apache.login.log4j.co look up the keys related to Java version, JRE version and VM version and so on. The Java lookups allows the environment information to be retrieved in a convenient pre-formatted string using Java prefix. Here the key runtime, the Java runtime version like Java TMSC runtime environment build 1.7.0 _67-B01 from Oracle Corporation. the VM, here the Java VM version, here the OS, Java OS version. Now we are considering JNDI lookup. When using LDAP, only references to the local host name or IP address are supported along with any host or IP addresses listed in the log4j 2.allowed LDAP host property. As of log4j 2.15.1, JNDI operations require log4j 2.enable JNDI equal true as be set as system property or the corresponding environment variable for the lookup to function. The JNDI lookup allows variables to be retrieved via JNDI. By default, the key will be prefixed with Java :comp/env/. However, if the key contains colon, no prefix will be added. By default, JNDI lookup only supports Java, LDAP and LDAPS protocols or no protocol. Additional protocols may be supported by specifying them on the log4j 2.allowed JNDI protocols property. When using LDAP, Java classes that implement the references the referenceable interface are not supported for security reasons. Only Java primitive classes are supported by default, as well as any classes specified by log4j 2 allowed LDAP classes property. When using LDAP, only references to the local hostname or IP address are supported along with any host or IP addresses listed in the log4j 2.allowed LDAP host property. Java's JNDI module is not available on Android. Now we are considering JVM input arguments lookup JMX. Use the prefix JVM run args to access JVM arguments. The interface runtime, the method list type parameter string get input arguments in the interface runtime mxbin in java.lang.management in compact with the compact 3. The writer returns the input argument passed to the Java virtual machine, which does not include the argument to the main method. This method returns an empty list if there is no input argument to the Java virtual machine. Class JMX runtime input arguments lookup in package org.apache.login.log4j.core.lookup in module org.apache.login.log4j.core maps JVM input arguments but not main argument using JMX to acquire JVM arguments. The maps JVM inputs arguments but not the main arguments using JMX to acquire the JVM argument. Use the prefix JVM run args to access JVM argument. The Java's JMX module is not available on Android or on Google App Engine. Now we are considering Kubernetes lookup. Here's the example usage. The Kubernetes lookup can be used to look up attribute from Kubernetes environment for the container the application is running in. Log4j Kubernetes provide access to the following access to the container attributes. Now we are considering map lookup. Note that when used this way, the value for type should be declared in the properties declaration to provide the default value in case the message is not a map message for the map message, or the map message does not contain the key. Class map lookup in package log4j.co.lookup. Module in module log.apache.login.log4j.co. A map based lookup. A map lookup serves several properties. One, they provide the base for properties declared in the configuration file. Two, the retrieve values from the map messages in the log events. Three, the retrieve values set with the map lookup dot set main argument string. The first item simply means the map lookup is used to substitute properties that are defined in the name defined in the configuration file. These variables are specified without a prefix. For example, $ open curly brace name, close curly brace name, close curly brace. The second usage allows the value from the current map message if one part of the current log event to be substituted. In the example here, the routing append will use the different ruling file append for each unique value of the key named type should in the map message. Note that when used when used this way, the value of the type should be declared in the properties declaration to provide the value default value in case the message is not map message or the map message does not contain the key. The marker lookup allows you to use the markers in interesting configuration like routing append. Consider the following YAML, this YAML configuration and code that logs two different files on the markers. Not the key part of the configuration is pattern $& marker here. This will produce 3 log files, each with log event for a specific marker. Log4j will route the log event with SQL marker to SQL .log. The log event for payload marker for payload.log and so on. You can use the notation $ marker colon name and the $ open curly brace marker colon name close curly brace to check for the existence of marker name. Is a marker name. If the marker exists, the expression returns the name, otherwise null. Now we are considering structured data lookup. The main difference between the example here and the example in map message is that the type is an attribute of the structured data message, while the type would have to be an item in the map message. The class structured data map in package log4j.login.log4j.co.lookup in module log4j.login.log4j.co lookups keys from the structured data message log messages. The structured data lookup is very similar to the map lookup, and in that it will retrieve values for structured data messages. In addition to the map values, it also returns the name portion of the ID, not including an enterprise number and the type field. The main difference between the example below is the example for map message is that the type is an attribute of structured data message, while the type would have be an item in the map message. Now we are considering stream boot lookup. The Spring Boot lookup requires log4j spring boot jar to be included as a dependency. The Spring Boot lookup retrieves the values of the Spring properties from the Spring configuration, as well as values of the active and default profiles. Specifying a key profiles.active will return the active profiles, while the key of the profiles.default will return the default profiles. The default and active profiles can be an array. If more than one profile is present, they will be returned as a comma separated list. To retrieve single item from the array, append open square bracket and then open curly brace, index, close curly brace and close square bracket to the key. For example, to return the first active profile in the list, specify here the profiles active here 0. This lookup will return null values until Spring Boot initializes application logging. The Spring Boot lookup requires log4j-spring-boot jar be included as a dependency. This lookup requires log4j-spring-cloud-client be included in the application. Now we are considering a system properties lookup. Class system properties lookup in package log4j.login.log4j.co.lookup in module log4j.login.log4j.co looks up the keys from the system properties. As it is quite common to define values inside and outside the application by using system properties, it is only natural that they should be accessible via a lookup. As system properties are often defined outside the application, it would be quite common to see something like this. This lookup supports the default value syntax. In the sample here, when the log path system property is undefined, the default value /var/logs is used. Now we are considering upper lookup. Presumably the value will be the result of the nested lookup. The class upper lookup in package log4j.login.log4j.co.lookup in module log4j.login.log4j.co converts values to uppercase. The passed in the key should be the value of another lookup. The lower lookup converts the passed in argument to uppercase. Presumably the value will be the result of a nested lookup. Now we are considering web lookup. If the key is located, then the corresponding value will be returned. The web lookup allows application to retrieve variables that are associated with the servlet context. In addition to being able to retrieve various fields in servlet context, the web lookup supports lookup variables stored as attributes or configured as an initialization parameters. Here the key root dir returns the result of calling get real path with value of /. Any other key names specified will first be checked to see if a server context attributes exist in that name, and then will be checked to see if an initialization parameter of that name exists. If the key is located in the corresponding value, if the key is located, then the corresponding value will be returned. Now we are considering request lookups and asynchronous calls. During this task execution, the lookups will be set up properly. The servlet 3 supports asynchronous calls. By default, the request tracking and therefore request related lookups will not work. To make it work, you can extract the server context attribute Log4j request executor, which is a by consumer servlet request runnable, and call it passing the correct request and task to execute synchronously. During this task, the execution lookups will be set up properly. Example using JAX-RS asynchronous feature backed by servlet async context. Now we are considering enabling message pattern lookups in configuration. The message is processed by default without using lookups. For example, if you define here, then the logger.info here will output this one here instead of foo_bar. You could enable message pattern lookups by defining the message pattern using this. Now we are considering lookup variables with multiple leading $sign here one characters. An interesting feature for StrLookup processing is that when a variable reference is declared with multiple $sign characters, each time the variable is resolved, the leading $sign is simply removed. The previous example, the root element is capable of resolving the variable at runtime. To allow this prefix value is specified as a variable with two leading $sign characters. When the configuration file is first processed, the first $sign character is simply removed. Thus, when the root element is evaluated at runtime, it is the variable declaration, like here, when which causes the event to be inspected for a structured data message, and if 1 is present, the value of its type attributes to be used as the routing key. Not all elements support resolving variables at runtime. Components that will specifically call that out in their documentation. If no value is found for the key in the lookup associated with the prefix, then the value associated with the key in the properties declaration in the configuration file will be used. If no value is found, the variable declaration will be returned as the value. The default values may be declared in the configuration by doing here. As a footnote, it is worth pointing out that the variables in a rolling file append declaration will also not be evaluated when configuration is processed. This is simply because the resolution of the whole rolling file element is deferred until the match occurs. Now we are considering lookups in extending Log4j3. The example here shows the lookups that will return the value of a system property. Lookups are here the annotation type. Here the annotation type str annotation type lookup. The package in package apache.login.log4j.co.lookup in module log0apache.login.log4j.co. The plugin namespace for StrLookup plugins. Lookups are the means which the parameter substitution is performed. During configuration initialization, as an interpolator is created that locates all the lookups and registered them for use when a variable needs to be resolved. The interpolator matches the prefix portion of the variable name to the registered lookup and passes control to it to resolve the variable. The lookup must be declared using @plugin @lookup annotation. The value specified in the @plugin annotation will be used to match the prefix. This example here shows the lookup that will return the value of system property. The provided here the lookup the value for a key @param key, the key to be looked up and may be null. The return value for the key here, and here the lookup for the value for key using the data in the log event. The parameter event, the current log event, the param key, the key to be looked up may be null. The return value is the value associated with the key. Now we are considering lookups in plugins. Lookups are the perhaps the simplest plugin at all. They must declare their type as lookup on the plugin annotation and must implement the StrLookup interface. The interface is StrLookup. The package log4j.co.lookup and in module log.apache.login.log4j.co. The lookup a string key to a string value. They will have two methods: a lookup method that accepts a string key and returns a string value, and the second lookup method that accepts both log event and a string key and returns a string. Lookup may be referenced by specifying $, / open curly brace name : key close curly brace, where the name is specified in the plugin annotation and key is the name of the item to locate. As an exception example, we can consider this occurred in the log4j with the environment with log4j2 and JSON. JNDI lookup class is not available because this JRE does not support JNDI. JNDI string lookups will be available continuing configuration, and then java.lang classcast exception cannot cast org.apache.login.log4j.code.lookup JNDI lookup to org.apache.login.log4j.code.lookup.str lookup.